Okay, in the human body, if the length of a bone is larger than its width, then it is classified as a long bone. The tensile stress FOA, strain delta L over L curve for the certain long bone is shown in figure 1. Here all symbols have their usual meaning. Part 1. Identify the point P and Q marked on the curve shown in figure 1. We know that point P is proportional limit. Proportional limit. And point Q is breaking point. Breaking point. Then part 2, assume that the long bone is a uniform rod of area of cross-section 3 into 10 to the power minus 4 square meters. If a tensile force of magnitude 4.5 into 10 to the power 3 is applied, calculate the tensile stress. Tensile stress means we have to find the ratio between force over area. F over A is the tensile stress. Tensile stress. Force 4.5 into 10 to the power 3. Area 3 into 10 to the power minus 4. Then we can simplify 4.5 divided by 3, 1.5 into 10 to the power 7 Newton per square meter. Force divided by area, unit Newton per square meter. Then part 3, if the Young's modulus of long bone is 1.5 into 10 to the power 10, calculate the tensile strain of the bone. Strain means extension divided by initial length. We can use, according to Hooke's law, F over A equals Y E over L. I will use E for the extension. They have given delta L over L. Force of area is 1.5 into 10 to the power 7. Young's modulus is given as 1.5 into 10 to the power 10. We have to find extension over initial length. We can cancel out 1.5 and 1.5, 10 to the power 7, then 10 to the power 3 remaining. Then we can get E over L is 10 to the power minus 3. There is no unit because of extension and initial length. Both are lengths. In part 4, if the initial length of the long bone is 25 centimeters, what is the length when tensile force is applied? Now we can get extension over initial length is this value, 10 to the power minus 3. Then extension is 10 to the power minus 3 times initial length. 10 to the power minus 3 times initial length 25 centimeters. We can substitute in centimeters, so we can get in meters. I will use meters. 25 centimeters, we can write it 25 divided by 100 meters. Then 25 into 10 to the power minus 5. Then we can get 0.00025 meters. It is the extension. Therefore, final length is initial length plus extension. Initial length 25 centimeters, it means 0.25 meters, plus extension is this one, 0.00025. Then we can add 0.25025 meters. Part B. Table given below shows the elastic characteristics of one of the long bone of human body. The femur, the long bone in the thigh, obtained under tension and compression. They have given Young's modulus and Young's modulus, stress corresponding to the fracture point, strain corresponding to the fracture point for tensile value and compressive value. Part 1, using the values given in table above. For the femur, show that the same value of stress, the compressive strain is 1.6 times of tensile strain. We can get that B part 1, E of L for the compressive divided by E of L for the tensile. E of L for the tensile there is the same force. They have given force is constant. Then according to F of A equals Y of L, this value is constant. They have given same value of stress. Then E of L inversely proportional to Young's modulus. Then we can get E of L compressive should be equal to Young's modulus for the tensile value 1.6 into 10 to the power 10 divided by Young's modulus for the compressive value 1 into 10 to the power 10. We have to use opposite direction. This one is compressive, therefore Young's modulus for compressive in denominator. This one is for tensile, Young's modulus for the tensile is for in numerator. Because of there is an inversely proportional relation. Then we can get that it is 1.6. Part 2, under which condition tensile low compression the femur is more susceptible for fracture. Use the value given in the table above to justify your answer. We can get that compression stress, it is given 1.65 into 10 to the power 8, and for the fracture point tensile value 1.2 into 10 to the power 8. Therefore 1.65 into 10 to the power 8 is the greater value. Then we can get stress corresponding to the fracture point. Under compression is a greater value. Therefore we can obtain it will susceptible for the fracture under the tensile. Then we can write under the tensile because of stress corresponding to tensile is less than stress corresponding to the compression. Part 3. When a person stands on a single leg, the total weight of person creates a compressive effect on the leg. Consider the situation that one of the firmers supports to entire body mass 75 kilograms of a person who is walking. Consider that the firmer is a thick-walled cylinder of uniform cross-section with an inner cavity. Its outer and inner radii are 1.5 centimeters and 0.5 centimeters respectively. For the following calculation, use the values given in the table above. Part 1. When the person stands on a single leg, find the compressive stress applied to his femur. We can obtain compressive stress FOA. Force is 75 kilograms. It means 75 into 10 newtons. And we have to divide by cross-sectional area. When getting cross-sectional area, they have given that it is a hollow cylinder. Then we have to get this area. Then we can get 5r squared minus simple r squared. Simple r means small radius of hole, and capital R means outer radius. Outer radius capital R, inner radius simple r. Then we have to substitute values and simplify. 750 divided by 5 value is given as 3. We can use difference between two square terms, factors. Then 1.5 plus 0.5, 1.5 minus 0.5. It is in square centimeters. We have to convert it to square meters. We have to multiply by 10 to the power minus 4. Then we can simplify it. Divide by 3, 250. 250 divided by 1.5 plus 0.5, 2. 1.5 minus 0.51. We can bring 10 to the power minus 4 to the numerator as 10 to the power 4. 250 divided by 2, 125 into 10 to the power 4. It means 1.25 into 10 to the power 6 Newton per square meter. Part 2. Find the strain corresponding to situation in C1 above. Then we can get Hooke's law. This one is C part 1. Now part 2. FOA equals Y EOL. We have to find EOL. Then we can get FOA divided by Young's modulus. FOA is this value. 1.25 into 10 to the power 6 divided by Young's modulus is 1 into 10 to the power 10 for the compressive value. 1.1 into 10 to the power 10. Then we can obtain 1.25 into 10 to the power minus 4 meters. Sorry, there is no unit because of it is the ratio between two legs. For a human to stand on a single leg without feeling uncomfortable under ordinary standing condition, the strain to the femur must be less than 1% of value of the strain indicated in the table above. Hence, so that when the mentioned person stands on one leg, he does not feel uncomfortable. First of all, we have to find 1% of given strain value. One percent of 1 over 100 of given the strain value is in the table is 1.75 into 10 to the power minus 2. It is 1.75 into 10 to the power minus 4. We have found strain in part 2. 1.25 into 10 to the power minus 4. Therefore, we can write it is greater than 1.25 into 10 to the power minus 4. Therefore, he can walk without an uncomfortable. Consider a person having all body dimensions doubled, increase in all bones compared to an ordinary person. Let the mass such person to be 600 kilograms. If the scaled up person now stand on one leg, does he feel uncomfortable? Justify your answer. Assume that elastic characteristics given in the above table remains unchanged for the situation. Then we can find new E of L value, new strain. When finding strain, we have to get F over A1. We have found it in previous calculation. Force is 600 kilograms, it means 600 times 10 newtons. Divide by, when getting area, we can get 5 r squared, 1.5 minus 0.5, 1.5 plus 0.5. Now they have given all dimensions doubled. It means area should be 4 times of this value. Young's modulus, same as the previous one. Before it we have to convert this square centimeter value to square meters, and we have to get Young's modulus 1 into 10 to the power 10. Then we can simplify this value by using 5. After simplifying, we can obtain it 2.5 into 10 to the power 4. This value is greater 10 to the power minus 4. This value is greater than this one. It is greater than 1.75 into 10 to the power minus 4. Therefore, he does feel uncomfortable.